Hi Gladys, let's go over homework number 16, question number 6 in this video. So let me open it up. Alright, what is this one about? Ideally, the results of a statistical analysis should not depend greatly on a single observation. For the weight changes in the table from anorexia study, the greatest reported value of 20.5 pounds was a severe outlier. Suppose this observation was actually 2.5 pounds but was incorrectly recorded. Oh, okay, so they made a typo. Huh? The original result of the test resulted in a test statistic of 2.25, a p-value of 0.033, and rejecting the null hypothesis. Redo the two-sided test, H0, where it stated that mu equals 0 with the significance level of 0.05 and summarize how the result differ. How does the ultimate conclusion depend on that single observation? Okay, so we're going to just do a test one more time. So they state the alternative hypothesis and they didn't really say any, I don't really see a direction when I was reading it. So, okay, so we're going to go with the two-sided. So that was given. But now let me go ahead and find the test statistic. So you enter something over here. Let me just, oh, it's just final check. I'm scared. I'm not going to go ahead and click it. But 2.21, that was the answer that was typed up here when I clicked on the link. But let me go ahead and see. What is this? Oh, all right. So the weight changes in anorexic girls. So some are positive, some are negative. So I guess some gained weight, some lost weight. I'm gonna go ahead and open this up in StatCrunch. And we're gonna do a hypothesis test. And what kind of test? We're gonna do a t-test. Why? Because we don't know the population standard deviation. So go ahead and open up t-stats, and one sample, and with data. Tell them that the variable isn't saved in variable 1, the column 1. And then we're going to go ahead and click on the mu is the alternative, the null hypothesis, assuming that mu is 0. And it looks like the alternative, we're going to go with mu does not equal to 0. So we will go ahead and click on compute and report the test statistic, which is 2.25. I will go with 2.25. Okay, it's given right there. So 2.25. And hopefully they're going to ask me for the p-value. Oh no, what happened? Oh, I know what happened. I know what happened because they did say change that value. I did not change that value. Remember, they said don't use 20.5. They said use what? This was recorded incorrectly. We better change that to 2.5. Oh, that's what it was. I wasn't paying attention there earlier. So before we get the test statistic, we need to change that to 2.5 because they did say redo the test with the, no, where was it? Suppose this observation was actually 2.5 pounds, but was incorrectly recorded. So I had to change that first. So let me run this one more time and see if we get 2.02 this time, okay? That was my oopsie moment. So go to t-stat, one sample with data, and then we just keep everything the same and compute it. Yeah, that's how we get the 2.2 right here. Sorry about that. But now they're going to ask you for the p-value, and the p-value is 0.0534, rounded to 3 decimal places. We're going to go ahead and report that. So this one, I had to actually change the data, one of the observation, which had a typo, to 2.5 to get the right test statistics. Since that p-value is greater than the level of significance, so that we're not going to be able to reject it. So we do not reject the null hypothesis. There is not significant evidence that the population mean is not equal to 0. Okay, so that's what we're going to have to say. Now, I like this problem a lot because we have to not only run the test, but change, if there's like a typo in the data, we have to change that to the correct value. So the original conclusion they said with the typo was that they rejected it. But when we changed that value down to 2.5 instead of 20.5, we were able to get a different p-value that was slightly greater than the 0.05. So the conclusion completely changed. I like this problem a lot. Thank you for sending me this. Let me know if you have any other questions, okay? Oh, one more. After changing 20.5 to 2.5, the test statistics, it decreased and the p-value increased. The original test on the null hypothesis was rejected, and after the adjustment, the null hypothesis was not rejected. The conclusion, does depend on the single observation. And that is really it. Now I gotta keep this video short because I think my account with this screen screen recording thing kind of expired, so I may not be able to record something longer than I think like 6 or 7 minutes. So sorry that I was talking so fast, but hopefully I explained everything. Okay, alrighty.